Okay, a particular scenario I want to show you with this is sometimes you have something that at first glance you think, oh, I can just cancel those. Because if inverse sine means doing the opposite of sine, then why can't we just go ahead and get rid of all this and just cross them out and say, okay, that's 7 pi over 6. Can we?
No, because you like the way that you said it was like we can't. So.
That's true. We can't. Why not?
Because he said so.
Because inverse sine, what quadrants do we look in? 1 and 4. Is this value in 1 or 4? No. So we can't do that. Okay? So we still have to work it out. So we find the sine of 7 pi over 6. Sine of 7 pi over 6 is negative 1/2, I believe.
Yes.
Okay? So then we do the inverse sine of negative 1/2, and we have to look in the first quadrant or the fourth quadrant. Fourth quadrant is where we look for a negative sign. And we find right here at negative pi over 6 that we will find that value. So that's my answer. Yes, sir.
I just want to clarify. So it's only with the fourth quadrant.
Yes. Yes. Yes, sir.
So say for example, if that wasn't sine, or like it said, secant, or
Let's do another one.
something like that. But like we would solve it normally, and then we would find it like the same way that we've been always solving it for like 1, 2, 3,
Yeah.
4.
Basically, the rule of thumb is don't try to cancel. Go ahead and just work it out. Sometimes canceling would theoretically work, but canceling is not really a thing because it doesn't always work. So just go ahead and work it out. So like cosecant of 2 pi over 3. Cosecant of 2 pi over 3. 2 pi over 3. What does cosecant go with? Sine. It's the reciprocal of sine, right? So it's the reciprocal of square root of 3 over 2. The reciprocal of square root of 3 over 2 is 2 root 3 over 3. Because if you take square root of 3 over 2 and turn it over, you get 2 over square root of 3, but then you have to rationalize.
Wait, why did we have to turn it over?
Because cosecant is the reciprocal of sine. Cosecant's not on the unit circle, but sine is. So I take the sine and I flip it over. Okay? So then I have this. And I'm finding the inverse cosecant of that value. Where do we look for cosecant? Where did I put your worksheet? There it is. On your worksheet, you got this little handy reminder. Cosecant's in first and fourth quadrants. Okay? This is positive, though, so I don't need the fourth quadrant anyway. So I'm looking for where in the first quadrant the cosecant would be this. Well, we just talked about how the cosecant being this number means the sine was square root of 3 over 2. So where in the first quadrant is the sine square root of 3 over 2? Pi over 3. And that's my answer. Okay? Another scenario that comes up is when there are values that are not unit circle values. If you have something that is not a unit circle location, then you have to draw a right triangle. So let's look at these. Okay? Inverse sine of 4 over 5, and I'm going to take the sine of that. Okay? So inverse sine of 4 over 5. 4 over 5 is positive or negative? Positive. So what quadrant would I do it in? First quadrant. So here's what I'm doing. I'm drawing a terminal side in the quadrant that I know to draw it in. If this was negative, I would draw it in the fourth quadrant. Okay? This is positive, so I'm going to draw it in the first quadrant. And then I'm using SOHCAHTOA. Sine is opposite over hypotenuse. So that means the opposite is 4, the hypotenuse is 5. Okay? Usually you then have to find this side. What would it be in this case? 3. You use the Pythagorean theorem, but this is a Pythagorean triple, so it's one you should probably know. And then you can take the sine. You're finding the sine of this angle now, basically. So it's 4 over 5. That's why I said usually, is this time we really don't need that side. And it is just going to be 4 over 5. So like I said, sometimes canceling would work, but it's not really a thing, so you should work it out. Okay? Let's look at this one. Okay. Tan of inverse cosine of 4/5. 4/5 is a positive number, so I'm going to do it in the first quadrant. Positive numbers always go in the first quadrant, which means you draw your terminal side sticking out into the first quadrant, then go to the x-axis to make your triangle. So draw terminal side, then go directly to the x-axis. That's where your triangle is. It would never look like this. Okay? So cosine is adjacent over hypotenuse. So again, I would use the Pythagorean theorem to find this side. It's not always going to be this nice and tidy. Sometimes it'll be a radical, but this time it's a whole number. And then I've figured out where my angle is, and I find the tangent of that angle. What's tangent? Right, or in terms of SOHCAHTOA, opposite over adjacent. So the tan of this angle is 3/4. So that's what happens if you have one that's not unit circle. You actually have to draw the terminal side and make a triangle. Yes, sir?
If you feel more comfortable with the triangle method, could you do that for one that is on the unit circle?
Yeah. Let's do an example one. You should be pretty comfortable with your unit circle, though. Let's do... I don't want to do cosecant. Let's do secant. And that's a really good question. Okay, let's do it the way we were doing it, and then we'll do it the triangle way. Okay? So sine, if it's negative, what quadrant do I look in? Fourth, okay? So I'm looking for a place in the fourth quadrant where I have negative square root of 2/2, and that's at negative pi/4. So all of this becomes negative pi/4, and I'm finding the secant of negative pi/4. The secant is the reciprocal of the what? Cosine. So negative pi/4, the cosine is square root of 2/2. Flip that over, you get 2 over square root of 2 and then have to rationalize it. Or, to me, it just helps to realize that square root of 2/2 is this. And then flip it over, it's just square root of 2. So this would be square root of 2. Is it negative or positive? Secant goes with what, right? Secant goes with cosine. Is cosine negative or positive in the fourth quadrant? It's positive. So this is my answer. So now let's do it with a triangle. Okay? First I look, I say, I'm doing sine, so I'm either going to be in the first quadrant or the fourth quadrant. Because this is negative, I'm going to draw it in the fourth quadrant. So let's draw it in the fourth quadrant. My terminal side sticks out into the fourth quadrant. Then I go from the end of it back to the x-axis. And this is my angle. Basically, there's my theta. So sine is opposite over hypotenuse. So this tells me the opposite is square root of 2 and the hypotenuse is 2. One of those has to be negative because it was negative. Which one is going to be negative? No, the hypotenuse is never negative. So don't ever make your hypotenuse negative. Okay? Then we just have to find this side. You could use the Pythagorean theorem, or we could use the fact that with 45, 45, 90 triangles, if you knew this was a 45, 45, 90, because 2 divided by square root of 2 gives you this, that's going to be square root of 2. But Pythagorean theorem would tell me this. So square root of 2 squared is just 2. 2 squared is 4. X squared is 2. So x is square root of 2. So here's square root of 2. And once you've got your triangle, you could find anything they wanted you to find. Tan, cotangent, sine, cosine, secant, whatever. This time it was secant. Secant is the reciprocal of the what? Cosine. And the cosine here, I'm going to write it well. Cosine of theta is square root of 2 adjacent over hypotenuse. So secant is hypotenuse over adjacent, or 2 over square root of 2. 2 divided by the square root of 2 is just square root of 2. So it does still give you the right answer. So when in doubt, you can definitely use the right triangle. Okay? Any other ones you want me to do from like 25 to 48 on here?
I do have one question.
Okay.
Say, for example, if it doesn't have the negative, the square root of -1 and like just it says tan, is that when you do the inverse of like what you
Can you give me an example? I mean, like if it just says tan, you just find the tangent of that angle.
Like say for example 25, if I found the cosine, the inverse cosine of 4/5, and I found that, would I, for my final answer for tan, would I have to switch that around?
Well, that's this one.
Yeah.
Okay, inverse cosine of 4/5. This is basically saying I want the tangent of the angle that has a cosine value of 4/5. That's what this is saying. So first you find the angle that has cosine value of 4/5, and then you find the tangent of that angle. Like I figured out where the angle would be, how the angle would be positioned to have a cosine value of 4/5, and then I went ahead and found the tangent for that same angle and got 3/4.
Okay. So what happens if it was in the unit circle instead of
Well, when in the unit circle, if the inverse is inside, it's basically saying where on the unit circle does this happen? Once you find the where, then it's just like those little quizzes we've been taking where it's like, okay, what's the cosine of that angle? What's the secant of that angle? You're working forward then. Instead of going backwards and saying, where did this happen? You're going forwards and saying, okay, so what's the sine of that angle? Or what's the secant of that angle?